I'm Anil Kumar. Welcome to my video, and let me thank all the subscribers and viewers for watching these videos so carefully and posting excellent question. Here is another very interesting question from one of our viewers. It is based on continuous probability. The question here is, a continuous random variable x takes values in the interval 1 to 3. The probability density function of x is given by f of x equal to k over x square. Determine the value of k. B. Find expectation and the variance of random variable x. C. Calculate probability when x is greater than or equal to 5 over 3. D. Calculate lower and upper quartiles of x. Let us try to understand the question first, right? So, in continuous probability, we normally talk about the probability density function, which is given right here. So, we are given probability density function, which is defined as f of x equals to k over x squared. So, graph of this function will be kind of decreasing like this, right? As x value increases. Now, we need to find the value of k. Now, for any probability density function within a given closed interval, the area under the curve should be 1, right? So, we need to calculate this area. If this area is equal to 1, then it is a valid function, right? Area for a continuous function can be calculated using definite integrals. So for part A, we are going to find the definite integral between the intervals 1 and 3 for the given function f of x. And we'll equate it to 1. From here, we can find the value of k. Correct? Now, once the value of k is known, then we really know the probability density function, and then we'll move on to part B, which is to find the expectation and the variance. Now, for all continuous functions, we are dealing with the population, correct? So, the average here, the mean is mu. The expectation E of x can be calculated by finding the integral 1 to 3 x times f of x dx. Since we know the value of k from part A, we know completely the function, so we can find expectation. As far as the variance is concerned, variance is equal to the expectation of x squared minus square of the expectation. Now we'll take the value of expectation, square it, and we'll also find the value of square of the expectation. Then we'll be able to find the variance. As far as part C is concerned, probability when x is greater than or equal to 5 by 3, we are going to find the probability in the interval from 5 by 3 to 3 for the probability density function f of x dx. Now, how do we find lower and upper bound? To find lower and upper bound, lower and upper quartiles. When we say lower quartile, we are looking for this value to be equal to 25%, right? So remember that. So for lower quartile, so the lower value, that is the integral from, in this case, 1, right? So 1 to lower bound of f of x d of x dx should be equal to 0.25. So we get the value for the lower quartile. For the upper quartile, we'll do the same, 0.25. For the upper quartile, we are looking for 75% of the value. Correct? So that is how we are going to calculate all these values. I hope the concept is clear to you. Now let's begin and solve the question. Now let's begin with part A. We are given the probability density function as f of x equals to k over x squared within the closed interval 1 to 3. Now sum of all the probabilities for this particular variable, the random variable x, should be 1. And how do we find the sum of all the probabilities? For a continuous probability distributive function is by integrating the density function in the given interval. So interval is from 1 to 3 and the function f of x d of x should be equal to 1. Now the function is given to us as k over x squared, where k is a constant. So let's find the integral of this function and equate it to 1 to calculate the value of k within the interval 1 to 3. Now here we are going to apply the formula which may be known to most of the students, but for integration, definite integrals, let's say if you are working in interval a to b, for x to the power of n d of x, the formula is x to the power of n plus 1 divided by n plus 1, right? Within the interval a to b. So applying this formula, we can write down the integral of this as this is x to the power of minus 2, right? So when you add 1, it becomes minus 1. So it is k times x to the power of minus 1, right? Divided by minus 1 within interval 1 to 3 equals to 1, correct? So what we did was, we wrote this x squared as, so we had this integral from 1 to 3, we wrote it as k times x to the power of minus 2 dx. Now when you add 1 to minus 2, it becomes minus 1, and we are dividing by the same exponent, which is minus 1. So I hope that makes sense, right? Now that really means that we'll subtract the value, or let me rewrite this as k is a constant, I can take it outside. Minus also I can take outside, and within this we have 1 over x. From 1 to 3, that should be equal to 1, correct? Now we can write this as minus k. If I substitute 3, I get 1 over 3, and if I substitute 1, I get 1. So 1 over 3 minus 1, that should be equal to 1. So that gives you the value as 3 is the common denominator, 1 minus 2 equals to 1, which is minus k, and this is minus 3, cross multiply. So that gives you minus 2 over 3 equals to 1, and when you take away, both negatives become positive. You get 2 over 3k equals to 1, or the value of k is 3 over 2. So for the value of k, 3 over 2, this probability density function will give us sum of probabilities as 1. So that is the only possible value for k. Correct? So that is how we find the value of k. Now let's move on to part B and calculate the expectation. Now let us calculate the expectation. We have the probability density function of x as f of x equals to k over x squared, where x is between 1 and 3. We just calculated that k is 3 over 2. So we can write f of x as equal to 3 over 2 x squared, right? Now, what is expectation? So expectation now can be calculated as the definite integral between 1 to 3 x times f of x. dx. So what we get here is integral 1 to 3 x times 3 over 2x squared d of x. This can be simplified just by cancelling x. We get this integral as equal to from 1 to 3 over 2x dx. Now how do you find integral of 1 over x? Well, the integral of 1 over x is ln x, right? So we'll just rewrite this expectation e of x as equal to 3 over 2 is a constant. We'll take it outside. Definite integral from 1 to 3 of 1 over x dx. Now integral of 1 over x is ln x. So we get 3 over 2 ln x 1 to 3. So that gives us 3 over 2 ln 3 minus ln 1. Now we can use the calculator to find this answer. So we have ln 3 minus ln 1, which you know is 0. So basically ln 3. We'll multiply this by 3 and divide by 2. The answer is 1.6479. So that is the expectation, right? So now let's move on, and we can now find the variance. Move on to the next part. Variance is equal to the expectation for x squared minus this value square, right? So that is what it is. We know now what is e to the power of x whole square, which is 1.6479 square. So let's rewrite this as a square also. So I'm going to square this answer, which is, we'll do square of our answer. It gives us a value of 2.7156. So we are going to use this value to calculate the variance. Now we need to find the variance. We know variance is expectation for x squared minus e of x whole square, right? So that is the variance. So we need to find the expectation of x squared first. So let's do it. We also know that the function k is equals to 3 over 2, right? So the function is 3 over 2x squared. So let's find what is the expectation for x squared. Is definite integral within the interval 1 to 3. Now this time we have to multiply by x squared f of x dx, right? We are trying to find expectation of x squared. Now that is 1 to 3 x squared times the function is probability density function is 3 over 2, that's the value of k, times 1 over x squared dx. Now x squared and 1 over x squared cancel, so we get 1 to 3. The constant function 3 over 2 dx, whose integral is equal to 3 over 2 is constant, right? So we'll write 3 over 2 outside and the value x from 1 to 3. Let's calculate this value. So we get expectation of x squared as equal to 3 over 2, 3 minus 1, which is 3 over 2 times 2, or equal to 3. Now the variance can be easily calculated. So variance is equal to the expectation for x squared minus the expectation whole square, right? So this is 3 minus, we just found that answer as 1 point. Let me just check that out. It was Let me write 1.6479 square. Right? Let's use the calculator to find the variance now. 3 minus 1.6479 square is equal to 0.284. So that is the value for the variance. Now let's move on and do the other two parts. Now let us find the probability for x greater than or equal to 5 by 3. So this probability is given from the density function by integrating it over the interval. It is greater than 5 over 3. So it is from 5 over 3 to the upper bound, which is 3, of the probability density function f of x. Now, since we found that k is 3 over 2, f of x is 3 over 2x squared. So we get from 5 by 3 to 3, 3 by 2x squared dx. Since 3 by 2 is a constant, we'll take it outside and integrate the rest from the interval 5 by 3 to 3. We could write this as x to the power of minus 2 dx. Now we are going to apply the integration rule to find the integral. So we get the probability for x being greater than 5 by 3 as equal to 3 by 2. So that gives you, add 1 to minus 2, you get minus 1. So we get this as x to the power of minus 1 over minus 1 from 5 by 3 to 3, which could be written as equal to 3 by 2. So minus outside, let me take minus outside, 1 over x from 5 by 3 to 3. So that gives you minus 3 by 2. We get 1 over 3 minus 1 over 5 of 3. So you could write this as 3 over 5, correct? So reciprocal of 5 over 3. So that gives you minus 3 over 2, common denominator being 15, we get 5 minus 9. So that is minus 3 over 2, and here we get minus 4 over 15. Minus and minus becomes plus. You can cancel 4 with 2, 3 with 5. So we get our answer as 2 over 5. So therefore, the probability for random variable x to be greater than 5 over 3 is 2 over 5. Now we are going to look into the quartiles. We'll find the lower quartile. We are given the probability density function of x as f of x equals to k over x squared. Since we know that k is equals to 3 over 2, we can write f of x as equal to 3 over 2x squared within the interval 1 to 3, correct? So when we talk about lower quartile, we are looking for the probability being 0.25, right? Quarter. So the integral from the lower limit 1 to the lower quartile for the given function, which is f of x dx, should be equal to 1 over 4 or 0.25. So substituting the value for density function, we get integral of 3 over 2 x squared dx. That should be equal to 1 over 4. And we know this integral is 3 over 2 is a constant. we need to integrate from 1 to L, which is x to the power of minus 2 dx. That should be equal to 1 over 4. And this is 3 over 2, 1 over minus x from 1 to L. That should be equal to 1 over 4, correct? Now we can equate and solve for L. So from here what we get is, it's better to write minus 3 over 2 outside as we did in earlier cases. We have 1 over L minus 1 is equal to 1 over 4. So we can cross multiply. So we get 1 over L minus 1 equals to negative of 1 over 4 times 2 over 3. Right? So which is equal to minus 1 over 6. Right? That goes 2 times. So we get 1 over L equals to 1 minus 1 over 6, taking this minus 1 to the right side. So which is equal to 5 over 6, or L is equals to 6 over 5. Correct? So we get the value of L lower quartile as 6 over 5. Now we'll do exactly the same process for the upper quartile, changing the limit definite integral from 1 to upper quartile, right? And then calculate the value when it is equal to 3 over 4 or 0.75. So the probability density function of x is given to us as f of x equals to 3 over 2x squared, where x is between 1 and 3, closed interval. To find the upper quartile, we'll integrate from 1 to the upper quartile the function f of x, the probability density function f of x, and that should be equal to 3 over 4 or 0.75. Now, as we did earlier, we are going to substitute this value, which is 3 over 2x squared d of x from 1 to u should be 3 over 4. 3 over 2 is constant, taking it outside. We get x to the power of minus 2 d of x should be equals to 3 over 4. And that gives you 3 over 2. You could write this as x to the power of minus 1 over minus 1. From 1 to upper quartile, u, 3 over 4. And now let's calculate the value of u. Taking this minus outside, is better to write this as minus 3 over 2, 1 over x, x to the power of minus 1 is 1 over x from 1 to u, should be equal to 3 over 4. Cross multiply. So we get, well, let me write like this first. 1 over u minus 1 equals to 3 over 4. Now let's cross multiply. So we get 1 over u minus 1 equals to minus of 3 over 4 times 2 over 3. So then 3 and 3 cancel. So we get negative 1 over 2, half. So we get 1 over u equals to 1 minus half, which is half. And that gives you the value of u as equal to 2. So the limit for the upper quartile is 2. So I hope the steps which we have taken are clear. Feel free to write your comments and share your views. This is a very important question. Share with your friends, and if you like and subscribe to my videos, that would be great. Thank you once again for posting this question for me. All the best.